Volcanic eruptions are one of the most powerful forces on Earth. From spectacular lava fountains to deadly explosions, they can bury entire cities under superheated clouds of ash and gas, or turn quiet rivers into seething torrents of mud and debris. Scientists are struggling to understand these unpredictable time bombs.
We were taken by surprise by what turned out to be an unprecedented event.
We'll circle the globe, profiling some of the most significant eruptions of our time, each more devastating than the last, each leading to a potential mega eruption that could change the world as we know it. Volcanic eruptions are dramatic reminders that our world is a living planet. Their destructive force is 4 billion years old, a force that commands respect. Volcanoes combine the beauty and the beast, the power to create and to destroy. From the very beginning, they've served a vital function, releasing heat, gas, and minerals from deep beneath the Earth's crust. These byproducts proved vital to human life, creating the Earth's atmosphere. If volcanoes did not exist, neither would we.
To me, they're one of the most beautiful things you can ever witness. But to the people who live under them, they're the most terrifying and destructive thing you can ever witness.
Cameraman Jeff Mackley's mission to film the world's volcanoes comes with risks. On one mountain, he avoided death by moments when a lethal mixture of hot gas and ash just missed him.
There was a loud roar like a freight train, and a pyroclastic flow came down the valley that we'd just been in. So, yeah, another 5 minutes either way, it would have been curtains for us.
Mackley risks his life to record volcanoes' beauty. Others risk theirs to record their power.
Many of us have experiences that could either have gone one way or the other depending upon just something small that happened.
In the past 60 years, volcanic eruptions have killed at least 27 scientists. Even so, their quest for knowledge continues. On average, between 50 and 60 volcanoes erupt every year. About 20 are erupting at any given moment. All are vents in the Earth's surface. Most take place within the Ring of Fire, an area around the Pacific Basin where tectonic plates collide, allowing molten rock or magma to be released. Thick magma loaded with gas triggers explosive eruptions. Thinner magma with less gas is less volatile. To compare and categorize eruptions, scientists have developed the Volcanic Explosivity Index, or VEI scale. Each notch up the scale means a higher ash cloud, more ejected material, and greater explosive energy. The events profiled here begin with a non-explosive eruption and peak with a planet-altering super-eruption, one that experts say will eventually happen. Hawaii is a stunning tropical paradise. But under the brilliant sand and lush forests simmers a cauldron of tremendous heat and violence. This is the site of one of the most spectacular volcanic creations on the planet. All of the Hawaiian Islands are volcanoes, built over 70 million years by a powerful geological formation called, appropriately, a hotspot.
A hotspot is a narrow zone which has an excess amount of heat in it. The heat rises, and relatively near the Earth's surface, this heat melts the rocks, and then that melted rock erupts as lava.
February 1983. Kilauea, on the Big Island of Hawaii, sends lava fountains 80 meters into the air. Because the magma is thin and doesn't contain much gas, the eruption is not explosive, but it's still dangerous. For 7 years, the eruption continues. The lava inches forward, slow enough to outrun, but totally unstoppable. In February 1990, it reaches the fishing village of Kalapana. Hundreds are evacuated.
It became a very painful experience, actually, to watch this because it was just creeping through town, you know. Every week or so, another block's worth of houses were gone.
Residents have time to pack up their belongings and in some cases their entire homes. Others can only watch as the lava destroys their past.
We moved out that afternoon, and 2 days later our home was engulfed by flames, and we were able to watch the lava come into our yard.
By December, the entire village is gone, buried under more than 15 meters of molten rock.
Behind me is the eastern edge of what used to be the town of Kalapana. In 1990, there were about 150 homes out here, and they've been buried by about 5 stories worth of lava.
Despite the hardships caused by the volcano, some Hawaiians see beyond their personal tragedy. They respect the power and the beauty of the lava, a force they worship as a goddess named Pele.
We don't really resent or feel like it was a loss for us, because we know that Pele, this is her land, her Aina, and she can come anytime she wants to and go anywhere she wants to.
The Hawaiians were unable to stop Kilauea's enormous lava flow. But 4,800 kilometers away, an entire nation took a desperate stand when a volcano threatened one of their towns. On January 23, 1973, the Eldfell volcano erupts on the Icelandic island of Hime. A slow-moving lava flow more than 10 meters high threatens to engulf the village of Vestmannaeyjar. The majority of the village is evacuated, but a dedicated team stays behind to confront the formidable force. Over 5 months, crews spray approximately 6 million cubic meters of seawater onto the lava flows. Nearly 4 million cubic meters of molten lava is converted into solid rock. The village is saved. Such a Herculean effort is impossible with Kilauea. The flow is simply too great. The lava that destroyed Kalapana plows on, pouring into the sea in a spectacular collision.
Where the lava goes into the ocean, it makes one of probably the most beautiful places on the flow field, but it's also one of the most dangerous.
Below the solidifying lava, unstable sand is prone to sudden and violent collapse.
All of a sudden, all this hot lava is on the surface, it just snaps off, the ocean rushes in, and it creates huge explosions that send gigantic plumes of material up in the air, and they cover maybe 3 or 4 football fields in area, sending out rocks the size of like soccer balls or basketballs all over the area.
This impressive display is a glimpse into prehistoric times when volcanoes first formed land. The same process is still happening today.
It builds new beaches, and then these beaches, the lava then can flow over, and it builds that out, a sequential set of beaches, and then lava flow and beach, lava flow, and it builds out a new piece of land that we call a lava delta.
Since 1983, Kilauea has displaced almost 200 families and destroyed millions of dollars worth of property. In that same time, it's added more than 200 hectares of land to the island, continuing the 70-million-year process that created all of Hawaii. It's a stunning example of how a volcano creates and destroys at the same time. Its slowly oozing magma is a permanent threat, but rarely produces a violent explosion. In our next event, thicker magma trapped in a geological powder keg triggers a much more explosive volcanic eruption. Lethal white-hot clouds of gas descend on thousands of people, wiping out an entire Caribbean capital. And later, in our mega-disaster scenario, a supervolcano strikes the heart of Europe, demolishing a major city and casting a shadow over the entire planet. The The stunning lava fountains and flows of Kilauea on the big island of Hawaii both create and destroy, but rarely are lethal. But there are much more explosive and dangerous volcanoes, ones that spew out deadly gas and ash clouds. One such volcano ravaged half a nation and sent 19 to their graves. Montserrat is a lush and tranquil Caribbean retreat. But in 1995, the Soufrière Hills volcano, quiet for nearly 400 years, rumbles back to life. Over the next 2 years, multiple eruptions shoot ash thousands of feet into the air. The capital of Plymouth is evacuated twice. Each time, the residents return, hoping the volcano's rage is over. On June 25th, 1997, those hopes are buried. At 1 p.m., a giant ash cloud erupts nearly 10 kilometers high. In the next 30 minutes, close to 800-degree mixtures of ash and rock race downhill at more than 100 kilometers an hour. The lethal clouds are called pyroclastic flows. Roy Daly lives 3 kilometers from the volcano. He hears the eruption and rushes outside to see the flow racing by him, less than 50 meters away.
Started to feel some heat, and the darkness started to roll over the road. So I got in my car and I sped away like crazy. I drove on top the hill, away from the pyroclastic flow.
The force of the thick mixture of gas, ash, and rocks flattens everything in its path. Roy watches helplessly as entire villages are destroyed. He's managed to escape the pyroclastic flows, but he's not out of danger yet.
I was scared to death. I thought I wasn't gonna live. It was so dark that if you put your hands to your face, you couldn't see them. Hot ash raining down on you, real hot ash. I felt scared. I couldn't move, I couldn't see, I couldn't breathe properly. So, of course, I felt I was gonna die. But I was hoping I didn't die, and I didn't.
Roy is finally evacuated by helicopter, but not everyone is able to escape. Dr. Sue Laughlin is the director of the Montserrat Volcano Observatory and a witness to the eruption.
The maximum speed of pyroclastic flows on that day could have been in excess of 150 miles per hour. Even though people saw it coming, there was very little they could do to make their escape.
The nearly 8 million cubic meters of flow covers thousands of square kilometers of land, damages or demolishes more than 100 homes, and destroys the island's only airport. Other than one ferry service, Montserrat is cut off from the rest of the world. But the volcano is not finished. Over the next 4 months, eruptions and pyroclastic flows continue to devastate the island.
We had over 70 explosions in 1 month. Sometimes there were 4 explosions a day. Each explosion generated a mushroom cloud which rose rapidly to great heights above the volcano. Each explosion generated pyroclastic flows which spread in all directions around the volcano. You can see behind me the impact on Gage's Mountain of surges as they came over the mountain during one of these explosions and singed and burned all the vegetation there.
The pyroclastic flow's toll on the island's natural resources is immense. The human toll is 19 lives. The cause of this violent and tragic eruption lies deep below the lush island. The same process that created this tropical paradise threatens to destroy it. Here, the North and South American tectonic plates collide with and plunge below the Caribbean plate in a process called subduction.
The subduction takes place at about 130 kilometers depth, that's about 80 miles below the surface of the Earth. As the plate goes down, parts of it melt, and this forms magma. And the magma works its way up to the surface over many thousands of years.
Unlike Kilauea, the Soufrière Hills volcano produces thick magma. Over thousands of years, it forms the classic steep volcanic cone called a stratovolcano. The magma contains a variety of gases, all under intense pressure. It slowly rises until it reaches the Earth's surface when the pressure is released. Just like a bottle of champagne, the gases suddenly expand and the volcano violently erupts. Thousands of kilometers away in Bari, Italy, scientists are studying Soufrière Hills' most lethal side effect.
The purpose of these experiments is to understand the dynamics of pyroclastic flows, so to be prepared for the next event.
Dr. Lolino and his team load about 200 kilos of actual volcanic ash from Mount Vesuvius into a cylinder. Pressurized gas creates an explosion that ejects the ash. The volcanologists track the height, direction, and density of the ash with a variety of instruments and high-speed cameras. The models here are big enough to be accurately scaled up to actual events, something that could not be achieved in a lab. The experiments have determined that both the amount of magma and the force applied to it are critical in the creation of pyroclastic flows. Next, researchers will match the test with the topography of specific volcanoes. They'll then be able to pinpoint specific areas where pyroclastic flows are likely to strike. Local authorities can evacuate those areas prior to an eruption, potentially saving many lives. But tragically, for those in the path of stratovolcanoes like Soufrière Hills, pyroclastic flows and ashfall aren't the only threats. Every year, between 1,200 and 2,000 millimeters of rain fall on Montserrat. Heavy rains run down the channels created by the pyroclastic flows, transforming them into massive mudslides called lahars.
Most of this debris that we see around us is caused by lahars, washing all the pyroclastic flow debris further down the hill and progressively burying Plymouth under all this mud and boulders.
Lahars have buried so much of Plymouth that the city has been permanently abandoned. They were the volcano's final salvo in a brutal one-sided war. The Soufrière Hills volcano destroyed more than 1,000 homes, left more than half of the island uninhabitable, and destroyed the nation's capital. About 4,500 people remain on the once thriving island of 12,000.
It was sad to see people just having to go by droves out of Montserrat. But it was understandable because these people had lost their properties. It was a pure strength why I stayed here. I mean, you had no place to go, no place to live with families and friends, being shacked up still in schools and churches. It was difficult and it was very sad.
But the volcano has also created new opportunities that have helped revitalize the island. Volcano-related tourism is rising. Roy Daly owns and operates a tour bus business.
People are anxious to see a live volcano. I don't think there's any place on the face of the earth that you could see a live volcano from approximately 1 mile from it bubbling and rolling and rocking, right?
Though Soufrière Hills' multiple pyroclastic flows and lahars were lethal and destructive, its eruptions never exceeded a 3 on the Volcanic Explosivity Index. But when a VEI-5 fires a single 24 megaton blast, it destroys thousands of acres of land and kills dozens of people. And later, scientists explore the potential for a super-eruption, one unseen in modern times, one that could kill millions. The pyroclastic flows and lahars of the Soufrière Hills volcano on Montserrat destroyed the island's capital, killed 19, and changed the nation's landscape and thousands of lives forever. In 1980, America's Pacific Northwest experienced a different and rare type of eruption that acted like a giant cannon blast. flattening entire forests and killing dozens. The Cascades are an 1,100-kilometer-long majestic range stretching from Canada to Northern California. Hundreds of thousands of hikers and skiers find refuge and adventure here. But in the spring of 1980, one of the Cascades' crown jewels begins to fracture. In March, small earthquakes ripple deep below the peak of Mount St. Helens. After more than 120 years of slumber, the mountain is awakening.
This seismicity is typical of volcanoes when they reawaken, because as molten rock tries to push its way up underneath the volcano, it makes a lot of noise in terms of shouldering aside the hard rock that makes the edifice of the volcano itself.
On May 17, Keith Ronholm, a geophysics graduate student intrigued by the mountain's activity, decides to get a closer look.
Mount St. Helens was erupting about every 5 or 8 days. I had gone to a place called Bear Meadow to try to get a view of one of these small summit eruptions.
Ronholm gets far more than he bargained for. At 8:32 on the morning of May 18, a magnitude 5.1 earthquake rips through the volcano's north side. 2.8 billion cubic meters of earth falls at speeds of up to 257 kilometers an hour.
I was reading a book in my truck when I heard some people yelling, and I looked over at the mountain, and the entire north side of the mountain was sliding down.
The Earth's movement releases the enormous pressure holding the magma inside the volcano. A 24-megaton blast, over 1,800 times more powerful than the Hiroshima atomic bomb, shatters the north face of the mountain. The blast is unusual in that it doesn't shoot straight up as most eruptions do. This is a rare lateral blast, slamming a huge cloud of rocks, trees, and ash approximately 180 degrees out from the mountain.
There was a puff of dark gray churning ash, and within 10-15 seconds, that ash had expanded out and had covered the entire mountain. All of this was happening silently, and it was no noise to reinforce my flight response. I was 10 miles away, and you don't, at least initially, feel like something's going to hurt you from 10 miles away. So I stood there and I took pictures, and I was fascinated by watching this event.
As the huge cloud of debris races over the two ridges between the volcano and Ronholm at 483 kilometers an hour, Keith suddenly realizes he's in serious danger.
As I'm driving out, I took one last picture over my shoulder, and it's a little motion blurred, but I couldn't take time to frame it or stop because I was driving, and I remember looking back at the little parking area, realizing that I was the last person to leave and thinking maybe I'd waited a little bit too long because this cloud was rushing towards me.
Luckily for Ronholm, the strongest part of the blast heads north and northwest. The portion that's heading northeast, directly towards him, has less energy, allowing him to escape down the mountain. The lateral blast spews ash and gas up to a height of 24 kilometers. Less than an hour later, a vertical eruption sends more ash skyward. Into this grim scene flies Jess Hageman with the Washington Army National Guard.
Most of the trees were blown over by the eruption, and we're talking about 14, 15 miles downstream of Mount St. Helens. The whole landscape was changed. It made you feel like sort of a gnat flying around the universe, because in comparison to the size of the eruption, it was amazing.
Amazing and horrific. 800-degree pyroclastic flows race down the steep flanks at up to 129 kilometers an hour. In some places, they are 37 meters thick. In the early hours of the disaster, the enormity of the destruction to the landscape is impossible to comprehend. But it only takes one sobering moment for Jess Hageman to realize the human toll.
It was on this ridge right straight ahead of us here that we found the first 2 survivors in the blast area. And that turned out to be Jim Skamanki and his partner, Leonti Skurkadov. And we eventually were able to pick those 2 people up. Leonti died in the hospital after we got him there, but Jim is still alive and survived.
Rescuers find a handful of stunned survivors, but the eruption kills 57, mostly campers and tourists. 9 hours after its start, the eruption ends. Scientists struggle to comprehend the enormous scope of the event. Before the eruption, Mount St. Helens stood at 2,949 meters tall. Now, it's 401 meters shorter. The blast destroyed enough trees to build 300,000 houses. Thousands of logs still litter Spirit Lake, 5 kilometers from the summit. The volcano shot out more than 508 million tons of ash that spread across the entire US in 3 days. 2 days after the eruption, geologists get their first close look at the desolation.
It was like walking on the moon. I have never seen anything like it. This entire area, which is 600 square kilometers or 230 square miles, was totally devastated. There wasn't a living thing in that entire area, not an insect or a bird or an animal. There was only one color, and it was this gray color of the deposits. The ground was covered with hot rocks, and there were fumes and hot gases coming out of the ground all over the place.
In the months following the eruption, teams of experts carefully study every facet of the mountain. One oddity of Mount St. Helens was that some people heard the eruption as far away as Canada, but eyewitnesses like Keith Ronholm, just 16 kilometers away, heard nothing.
Because of the way the temperature structure in the atmosphere gets cooler with height, that the sound waves from explosions are bent away from the surface of the Earth. And when they reach the stratosphere and the temperature again increases with height, they're bent back down. So no one between 6 and 60 miles from Mount St. Helens heard the May 18th eruption.
Since 1980, the mountain has experienced tens of thousands of small earthquakes and numerous minor eruptions. Most significantly, since 2004, the volcano has been continuously erupting lava, creating a giant lava dome that is still growing today. It's volcanologists like Rick Lahusen's job to find ways to monitor all of this activity.
What we needed was a way to get our instruments out there very quickly without putting people on the ground in harm's way, and yet still be able to monitor changes in the eruption. So what we came up with is this stainless steel superstructure, which kind of looks like a daddy long-legged spider, so we kind of call them spiders. This is a GPS antenna which receives timing signals from satellites and lets us locate exactly where this is. The signals go into the computer system, and then the data come out at the request from computers back in the office and are transmitted out through this antenna.
With the spider securely attached to a chopper, it's time to head into the belly of the beast. As they approach the crater, the new lava dome is visible, spewing out sulfur dioxide gas and steam. This is proof that magma is reaching the surface with the potential to build to another eruption. The most dangerous moment for Rick and his pilot comes as they place the spider on the lava dome. This close to the crater floor, exploding rocks or a sudden burst of steam could easily kill them. Operating with the precision of surgeons, the men carefully place the spider directly on top of the lava dome. Within seconds, the device begins gathering and transmitting data. At the Cascades Volcano Observatory in Vancouver, Washington, Lahusen analyzes the spider's digital camera images. Time-lapse photography shows the lava dome's formidable growth.
What's really phenomenal about this is how much rock is coming out of the ground. It's taller than the Empire State Building. It's coming up at 5 meters per day, more than 200 meters across, and it's right here in our backyard.
No conclusions have been drawn yet about the lava dome's rapid growth. Geologists warn that an eruption similar to the 1980 event is possible, but unlikely. They are certain, however, that future eruptions of some sort will occur. Whatever its future, the mountain's recent past continues to reverberate today, especially for those who were there.
It's just an amazing event to witness. That we normally think of the Earth as being a very static, stable environment that doesn't change. But when you get to watch a volcanic eruption and you watch a giant piece of the Earth slide away, followed by this dynamic, churning ash cloud that flattens tens of square miles of forest, you realize how powerful nature can be and how powerful geologic forces can be.
Mount St. Helens VEI-5 lateral blast destroyed a massive amount of land and killed 57 people. Just one notch up the scale, a VEI-6 volcano kills hundreds when its huge eruption is followed by a long series of deadly side effects. And later, scientists reveal the unthinkable effects of a mega eruption that they guarantee will happen sometime in the future. The VEI-5 lateral blast eruption at Mount St. Helens flattened 600 square kilometers of land and killed 57 people. But there's one volcano that's in a class by itself. It killed hundreds, afflicted millions, and affected the entire planet. Its eruption was just the first in a series of tragic events that went on for days, months, and years, that continue to this day. Luzon is the largest of the Philippine islands. It's home to 56 million people, the capital city of Manila, and Mount Pinatubo. For centuries, thousands have lived on and around the mountain. Farmers harvest rice and other crops from its fertile soil. What many locals didn't know or believe is that the mountain is a volcano. Even most experts who knew it was thought it was inactive. On June 9, 1991, the mountain erupts for the first time in more than 500 years. Eruptions, earthquakes, pyroclastic flows, and ash batter the island day and night. Geologist Dr. Kelvin Rodolfo arrives 4 days later.
The amount of ash was falling so thickly you couldn't see any more than 20 feet. There were pieces the size of chicken eggs that were landing on us.
On June 15th, a massive eruption spews 5 cubic kilometers of volcanic debris 35 kilometers high. The top of the mountain collapses, triggering a series of large earthquakes. Rodolfo is one of thousands trapped in the city of Olongapo, 33 kilometers from Pinatubo.
I was terrified continually during the eruption. Every 3 minutes or so, there was a noticeable tremor, one of the magnitude that would cause you impulsively to want to run outside of a building.
But outside, the scene is equally terrifying.
Reddish lightning was darting horizontally above people. And the claps of thunder were practically simultaneous with the lightning.
This intra-cloud lightning is caused by static electricity in the ash cloud. It's seldom dangerous because it strikes horizontally instead of vertically. Still, fear of the conditions outside stops many locals from sweeping the ash off their roofs, something that will have fatal consequences. On the same day as the eruption, a typhoon strikes Luzon. The heavy rains mix with the ash. Since ash consists of fine particles of rock and minerals, Adding water turns it into a cement-like substance. For those with several centimeters of ash on their roofs, the mixture is a deadly one.
The passing typhoon saturated the ash with water, making it a lot heavier, causing roofs to fall in and pull the walls of houses in after them.
As if that isn't enough, vast pyroclastic flows fill the valleys around Pinatubo with debris. Once again, the typhoon turns a volcanic byproduct into a lethal weapon: lahars. Lahars form when a large amount of debris rapidly mixes with a huge amount of water. The powerful mass churns downstream, destroying anything and anyone unlucky enough to be caught in their path.
If you imagine a bulldozer traveling perhaps 15 miles per hour, hitting the substructure of a bridge, the bridge is taken out, and that's the impact that large rafted boulders had.
After 9 nightmarish hours, the eruptions end. More than 300 people are dead, and tens of thousands are homeless. As bad as things are, they could have been much worse. In the months prior to the eruption, locals reported seismic activity. Ongoing scientific monitoring confirmed the reports. Guided by experts who pointed out specific high-risk zones, officials evacuated more than 58,000 people in the days and hours leading up to the eruption.
Prior to the eruption, we had made maps that anticipated where the tephra would fall, and that depended on the seasonal winds.
But in still another deadly development, the typhoon changed the wind direction. Areas that had been considered safe were inundated with a deadly mix of tephra, or ash, and rain that crushed homes and the people in them. As thousands begin the massive cleanup, the volcano's effects become global. 1 month after the eruption, the huge ash cloud circles the Earth. In the upper atmosphere, sulfur dioxide is converted into sulfuric acid aerosols. They reflect the sun's radiation away from the Earth, cooling the entire planet's surface by 1 degree. The effects on the Earth's atmosphere will last more than 2 years. Back in the Philippines, the volcano's after effects continue. In the 3 months following the eruption, heavy rains trigger more than 200 lahars.
As time progressed and the flows eroded deeper and deeper into the lahars, the channels got larger and larger and became much more efficient conduits for the slurries to flow down.
To help the hundreds of thousands of people in harm's way, lookouts are stationed upriver. When they sight a lahar, they radio priests like Father Nestor Tayeg, who ring their church bells in warning.
The bell sounds would be heard by the community any time of the night like an alarm, a warning. Warning, be prepared, lahar is coming.
But once again, a twist of fate conspires against the people of Luzon. In October 1995, another large typhoon strikes the island and lookouts are put on alert.
Unfortunately, the heavy rains that triggered the lahars were not yet loaded with sediment when they passed this watch point.
Consequently, the lookouts radio that nothing but floodwater is coming down the mountain. But as the water runs down the channel, it erodes a lot of loose material, bulking up the lahar into a mixture estimated at 80% sediment and only 20% water. The larger the percentage of sediment, the faster and more powerful the lahar. It strikes with incredible force.
It was making this noise, this sound, just like rampaging horses. It was coming closer. Suddenly, it invaded our parish church. The second floor of my rectory where I live was buried, and I climbed on top of the bell tower. The lahar still kept coming. You can actually hear the lahar still rising, burying the second floors of most houses. You can hear people screaming. It was very dark. You can't see a thing.
The lahar kills dozens and buries the entire town of Bacolor. Like cement, the remains of the lahar dry quickly and turn rock hard. Today, the entire village is built on top of the dried-out lahar. Eerie reminders of the devastation are everywhere, including Father Ness's church, where a new floor had to be built over 7 meters of mud. Since 1991, thousands of lahars have killed nearly 400 people and destroyed more than 42,000 homes. But scientists fear that Pinatubo is still not finished. On top of the mountain, a new threat is forming. Not magma, but years of heavy rainfall that have created a giant lake in the volcano's caldera. It breached its banks in 2002, generating a massive lahar. Geologists are concerned about a huge fault that runs through the area.
The rocks weakened by the fault are more easily eroded, and the walls of the channel are very steep, and so landslides could fall and plug the channel and cause the lake level to rise again and then spontaneously flush out in large amounts. That would generate new large lahars.
The lake contains 100 million cubic meters of water. 46,000 people live below it. All would be threatened by a major lahar. To date, the eruption and lahars have affected almost 2 million people. For the battered but resilient residents of Luzon, Pinatubo is a constant threat. For scientists, it's an ongoing spectacle.
In geological training, we are accustomed to thinking in terms of small events repeated over millions, tens of millions, or even hundreds of millions of years to generate mountains. But here we see events happening within a day. A huge amount of pyroclastic material, a huge hole developed over a matter of hours or days. And that, to me, is very fascinating.
The devastating byproducts of the Pinatubo eruption had long-term effects that killed hundreds, effects that continue to this day. But a mega eruption, one that volcanologists are certain will happen, could threaten millions. The VEI 6 eruption of Mount Pinatubo and its after-effects killed more than 700, sent a huge ash and gas cloud around the globe, and lowered the Earth's surface temperature. If we were to experience a VEI 7 super-eruption, it would be 10 times larger. It would destroy all life for dozens of kilometers. It would drastically change the Earth's climate, and scientists say it will happen someday. The 5 million people in the Naples, Italy area live in the highest volcanic risk zone in the world. Approximately 11 kilometers to the east is Mount Vesuvius. Its 79 AD eruption killed more than 20,000 in Pompeii and other villages. Since then, the volcano has erupted 50 times, most recently in 1944. Vesuvius looms over Naples as a constant threat. But 15 kilometers to the west is a far less conspicuous but potentially far more deadly volcano, Campi Flegrei. Campi Flegrei is an enormous 13-kilometer wide caldera with a series of craters scattered inside. 350,000 people actually live within the caldera walls. Since Campi Flegrei is not a tall, imposing volcano like Vesuvius, it attracts little attention. But volcanologists like Steve Self know the massive power it contains.
Here we are in the middle of a volcano that's got a remarkable history of eruptions since it was first formed about 35,000 years ago. This area has had repeated eruptions, forming the craters like the one we're in. We're in a volcanic crater that still has steam vents acting and hissing, as you can hear behind us.
These steam vents reach temperatures of nearly 700 degrees. To a casual observer, that's impressive. But to experts, the vents, along with ground shifts, are ominous warning signs. An indicator of Campi Flegrei's power lies in deposits left by a massive eruption 35 to 40,000 years ago. It was 10,000 times larger than the 1991 Pinatubo eruption. These 80-meter-tall cliffs in Sorrento, 30 kilometers from Campi Flegrei, are composed of volcanic material left from the super-eruption. Volcanologist Giuseppe Mastrolorenzo knows they are geological proof that enormous pyroclastic flows swept through this entire area.
The pyroclastic flow moved this way as a turbulent cloud and then emplaced en masse, thus causing the burying of all the area around Naples.
What scientists know about Campi Flegrei's past gives them a realistic model of what could happen in its future. The scenario begins with a massive disturbance somewhere within the vast caldera. A super-eruption. More than 242 cubic kilometers of dust, gas and pumice hurtle into the air.
It would bury very large areas, the size of a major city or more, in thicknesses of ash that are hundreds of feet thick.
Enormous pyroclastic flows race from the volcano at near supersonic speeds. Buildings that aren't already buried by ash are knocked down by the force of the flows, or incinerated by their 800-degree temperatures. The once proud city is completely annihilated. The death toll from the flows and ash is apocalyptic.
We can assume that in case of a super eruption, several million of people will be killed.
The casualties and destruction spread far beyond the immediate area. The eruption column grows to a staggering height of 30 kilometers. Heavy ashfall smothers towns near the caldera and spreads as far away as Rome, 225 kilometers away. The city is pelted with more than 20 centimeters of ash. Enough to cause roofs to collapse and kill thousands of people. Smaller amounts of ash fall across Eastern Europe and parts of Asia, but even small amounts of ash cause big problems.
Even a dusting of a few centimeters would create total disruption to transport systems, to water supplies, to things that we regularly rely on in our daily life. Enough to bury plants, enough to strip the branches and leaves off trees and things like that.
The enormous quantity of ash and sulfuric dioxide released by the volcano triggers a planet-wide condition, one affecting millions.
Atmospheric modelers are predicting that the temperature could drop several degrees centigrade, and this would affect weather for many years, 4 or 5 years perhaps, after a very large eruption. And temperatures would change, areas where crops would grow may not be able to grow those crops.
Huge areas of vegetation would die. Millions could starve to death. Ultimately, the entire planet and everyone on it would be dramatically affected.
If you consider the number of volcanoes, supervolcanoes around the world that could potentially produce super-eruptions, recognizing the fact that there are probably several out there that we don't know about yet, we've still got a huge amount to learn about this scale of volcanism, then there's possibly something like a 1% chance that an eruption could happen in the next 100 years, which is quite high, actually.
High enough for scientists to urge discussions of this type of disaster in the international community. Volcanologists know that there is no way to prevent an eruption. So they learn from the past and study the present in order to help mankind prepare for the future.